Autonomous vehicles have different stages in a software control pipeline. Different techniques are suitable for use in each stage. At the vehicle control stage, this is traditional automotive software, and traditional software validation techniques should work just fine. The trajectory execution stage is mostly traditional control systems, and control software validation ought to do fine. Doer-checker architectural approaches can be helpful, but are not strictly required. The planning stage is a bit more difficult because it uses non-deterministic randomized and heuristic algorithms in some cases. Runtime safety envelopes can be very helpful here paired with a doer-checker architecture. As an example, the doer could try and find an optimized path through known obstacles, while the checker mostly is concerned about whether that path hits anything rather than the optimality of the path selection. Perception systems typically use machine learning-based approaches. The difficulty there is that it's hard to know how to build a checker to see if the perception classification was correct. While a safety envelope approach may help a little bit, in general, there's no known deterministic algorithms that can be validated at a high integrity level to ensure the perception is working properly. For the perception part of things, typically you see lots of simulation and a safety of the intended function sort of approach. A uniquely challenging aspect of this technology is that perception and predictions of future behaviors based on perception and other factors are uniquely difficult to validate and provide safety assurances for.